I made cyclostyle inlets for my centrifugal dust separator because I want to process large volumes of dust fast, without clogging. It pushed down the limits on what is possible with 3D printed parts that you can build yourself at home. So how fast is possible? This test was quite challenging, as the sharp bends in the flex hose pushed most of the dust through one single separation tube. It didn't clog, but the waste bin shows there's still room for improvement. For context, I built this beta version for my planer 1 year ago, and it's running without any issues ever since. Only why is this design not been featured in a proper testing video yet? After all, it's the most downloaded design on my Patreon site. And could these new inlets be the answer to our quest in achieving separation efficiency levels above 99.9% with normal feed rates? It's time to address these questions, and I was prepared for that, because this giant hole in front of the base plate wasn't there to save on weight. This endeavor for the new inlets started when I needed to address some clogging issues at very high volumes of dust and shavings that the basic separator was facing. To clarify, this feed rate only occurs when you have to vacuum large piles of dust at once. Even large tools like the planer produces many times less dust in the same time. And after all, we need challenges, right? So let's watch closely to see what is happening in the first stage. In theory, the small cone deflects heavy particles evenly to the impeller shroud, and they fall down eventually in the first waste bin. Only the air and light particles will make the bend around it towards the second stage impeller. Only that is not what is happening here. Large amounts of dust particles are hitting one spot due to the Y-piece in front of it. Extending the tube in front of the Y-piece doesn't improve it either. At first, I used this in my advantage by aiming the airstream more directly into the waste bin, and printed some new inlets for that. This free path was clearly visible when we looked through the Y-piece towards the waste bin, and it did make a difference, but it also introduced some uncontrolled turbulence. With some small refinements, this can certainly work when the dust comes from the top. Only I will mount it above my planer and underneath the cabinet, so I don't want to stick anything out from the top. So my dusting feed will come from the underside, and I think I found a way to take control over the turbulence and use it in our favor. I followed Michael Weiss's tip and designed cyclone-shaped inlets with the Y-piece at a 30-degree angle with slotted outlets. Dust will be divided by the sharp center of the Y-piece, and heavy particles move towards the outer diameter of the tube due to centrifugal force and make the turn into the bin. So some of you noticed that the turning direction on the intake was not the same direction as the impellers. And that was not by design, but due to my laziness. Back then, switching the tubes was not that easy and too much hassle, because the dust outlet ports on the second stage were not symmetrical. And I changed that in the video from December. So now I don't have any excuses anymore. And here's my plan to move forward. To do some proper testing, we need to move back in time for a bit with the design and remove the third stage integration that we have built in the last video. With some cheating, we reach a separation effectiveness of 99.9% with it. And maybe the cyclostyle inlets will outperform this. For this test to be effective, we first need to know how good the normal dual stage separator performs when large volumes of dust are processed. I connected the separator to a filter tube for easy quantification on the dust that is not separated out. It has 5 pleated filters with large filter area, so the resistance is very low. In theory, we don't need any filters on the ChemVac anymore, but I think that is cheating. After all, in the shop I can't use that large filter. It needs to be much more compact. And to reach the maximum performance of the ChemVac, I started a little side quest. So by default, the ChemVac is equipped with a paper bag that slides over a cotton bag and a cage that's on top of the motor. With that removed, we can test the airflow through the motor alone. The airflow is measured in meters per second, and when you multiply that with the surface area of the outlet tube, you will get that volume flow. I also did a test with only the cotton bag to see how much restriction the paper bag would have. Though the paper bag is very essential for filtering out the very small particles, but it will restrict the airflow substantially. I also try to further optimize the air at the motor intake by adding a velocity stack. They are commonly used in automotive engines and turbopumps, and in theory, the airflow is pinched down on the inlet without it. In my case, the result was not quite what I expected, and no measurable difference was noticeable. I ended up buying expensive Nanomax filters, because many influencers on YouTube say that they have the best filtration capacity at the lowest airflow restriction. I took their word for it, but I will make a separate testing rig for this, to find out if there are better local options available. For now, to summarize, on an outlet diameter of 58mm, we lose only 5% on air velocity compared to no filters installed, and gained 6% on the stock filters. And until I found something better, I will use the Nanomax filters moving forward. And the ChemVac? That definitely gained some weight. And I still use my MacGyver style brackets to secure it on the cleat wall. And now everything is ready, we finally can start with the first tests. I used my position check for the BT meter to figure out the new airspeeds with all the 3 motors enabled, in combination with the upgraded filters. That was quite impressive, but I forgot to remove the cotton bag. Maybe this will increase the airspeed even more. I was surprised though that the difference was not measurable. So for your reference, in my previous video I tested the airspeed with the ChemVac only and with a dual separator attached to it. Now with the updated filters we get airspeeds higher than that. Okay, now I also want to know the new airspeeds for the ChemVac only. It maxed out my BT meter when all the 3 motors are enabled. Impressive. And those results really raised my expectations. Now let's find out how fast we can process the planar shavings. To accurately measure the increased weight of the filter tube, I invested in a precision scale with 2 decimal places. And the filter tube must not move though, so patience is rewarded. And I know, this weighing process seems a bit cumbersome, but it's much simpler and more accurate than having to open the ChemVac every time. Now I just need to reconnect the tube for the measuring of the pressure loss and need some dosing of the planar shavings and distributing it evenly in the gutter. It's around 1.5 kg. I did 7 tests with increasing feed rates. This 8-second run was the fastest I could go. This 111 gram of dust was not separated out, and that was 92.8%. So at high feed rates, the efficiency drops very quickly. Now let's change the inlets to the new design and see how that will perform. These new inlets are made to be easily replaceable without having the need to change any additional parts inside of the separator. It started as a quick test version that eventually stayed the same ever since. And what also stayed the same, that was the airspeed. I could not measure any difference. Now for the dust testing, I did this time 9 tests with different feed rates. And it was at low feed rates that the efficiency almost touched 99.9%, with some inconsistent results at high feed rates. So I think that the main performance limitation is the dust distribution difference between the 2 tubes. So that made me wonder, what if we reduce the amount of tubes to 1 big tube? Only that needs some extra work. I made cutting jigs that slides against the edge of the tube for proper alignment of the dust outlet ports and used painter's tape to hold them in place. But while cutting the acrylic, it was melting and bounded together with the PLA jigs. So maybe next time I need some extra painter's tape between the jig and the acrylic. I learned my lesson from the last builds and gently made the dust balls fit, without cracking the acrylic. For the base plate I use my Shaper Origin to make it fit perfectly. It's my go-to tool for this, but you can also use the template to drill holes and use a jigsaw for the rest. What didn't quite fit were the holes, which were slightly undersized. To secure the front cone, I used a carriage bolt with a lock washer and a lock nut. Without this, the nut loosened over time. In the front dashboard there is a lip that fits into the impeller shroud to prevent it from moving inside of the tube. And I could have attached the whole thing to the base plate with just wood screws, but I used carriage bolts instead. This gives me more flexibility if I want to make changes later on. So because I'm Dutch, I reused as many parts of the smaller separator as possible and marked the shape of the waste bins to attach the compression tape to the right spot. With the twist locks in place, I faced the same mistake I made earlier, not nailing the right size, and needed my whole body weight to force it in place. And you don't see me use O-rings this time to make it more easily to build and scale. And with that, we have finished the dual stage system. And the third stage integration is something I will add later after the first tests. I was able to mount it on the wall with a little bit of cheating because of the high difference between the new separator and the old filter tube. But I really want to know how this will perform, so let's start with the airflow tests. In all the three situations, the airspeed increased with around 4 to 5%, and the resistance in millimeter water column raised with a lot when all three motors were enabled. So after a day of testing with different materials at different feed rates on the dual and the triple stage setup, I noticed some really interesting things that I want to share with you. It was the hose cut that started to act weird when all the three motors are enabled. And with normal feed rates of the dust, the efficiency was surprisingly good. Only when I increased the feed rates, the dust was forced to the top of the tube, on the intake, and hitting the first cone above the center. The dust got trapped on the shroud, and this killed the efficiency very fast. But I touched almost 99.99% at normal feed rates. That is 0.36 gram on 1.5 kilogram. I also collected 2 kilograms of MDF dust mixture from the shop's cabinet saw. It's super fine and very hard to separate. I took two different approaches for that. Which one do you think will perform the best? Keep your eyes on the swirling part. It's the one on the bottom that had only two motors enabled. With all the three motors, the airflow was much too high, which causes unwanted swirls in the waste bin, pulling up dust and moving it straight to the filter tube. Printing the new inlets was a tight fit on the normal build plate, but it printed perfectly, except that I forgot to chamfer the outer edge and also needed some extra heat to make it fit. There was a noticeable transition though, due to my laziness and scaling up the intake, and not compensating that for the reducer. It's an easy change and I repeated the test with the airspeed on average value and measured the pressure loss with my YouTube manometer. The pressure loss with three motors was 12% higher and the feed rates was a challenge on its own. All 5 tests scored above 90% and apparently I was quite happy with that. Damn, dat was voor 4 seconden 94%. Okay, now we are getting somewhere. But I think I have one extra trick up my sleeve. Because this inlet is just a quick scaled up version of my normal small separator. and I didn't change the hose diameter of the flex hose. So in theory, this is way too big. Now this is instead how it should be. And will that make a difference? I noticed a little bit less suction, and the pressure drop was 94mm water column instead of 88. And the measurements? Those went off chart. Now let's summarize. Do you really need the cyclone inlets? I think they are a very easy update, and the performance is above 99.7% at normal feed rates by plating shavings. When you want to excel on MDF dust, you really need the third stage integration to prevent the fine dust particles reaching your filters. And it's the bigger one, with the normal infeed, that really excels on the planer shavings with efficiency levels close to 99.99%. And to come back on your question about the turning direction of the airflow in the separator, you can see that for yourself. And that difference was hardly noticeable. Houdoe!